Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my channel. You have joined us for our physical science class. We are in chapter 7 about electricity, excuse me, and we are going to do a couple of problems. So this is part 2 of the electricity video. If you want to go back and watch part 1, it's up there. All right, so what we're going to do is a couple of problems. This is found in our physical science book on page 211, and we're going to do a problem that has to do with power. And remember I told you that all problems in physical science are word problems, math word problems, and what makes them hard is not the math, it's the words. So we just have to read the problem, get rid of all the words, make a list of our knowns and unknown numbers, figure out an equation to use, and then use it. All right, so here's our problem in the book here. It says the current in a clothes dryer is 15 amps. So there's our first number. So we stop, we go over to our paper, and we write that down. I is the symbol for current equals 15 amps. Okay, now we keep reading. When it's plugged into a 240 volt outlet, so now that's another number, so we're going to write that down, that the voltage, if you're not sure that it's telling you voltage, you look at the units, and the unit of voltage is volts. It's a 240 volt outlet, so we wrote that down. Keep reading. How much electric power? So my question word, how much, goes with power, does the clothes dryer use? So for power, I put a question mark. Then I ask myself, is there a formula that relates current, voltage, and power? Why, yes, there is. The power equation. Power equals current times voltage. I write it down every single time. Write your formula. It will make you memorize it, and it will get it all in your head real good and strong. So always write your formula every single time. Now we sing a song. Do you remember the song? It's Substitute by The Who. It's before my time and yours, unless you're a lot older than me. And that means right underneath the values, we write what they are. So underneath current, I put 15 amps. Underneath voltage, I put 240 volts. You can put the units there or not. I like to put the units there, but when I do the videos for you guys, I don't want it to look too messy, so I'll leave them off a lot of times. Okay, then I do the math. 15 times 240, I go over to my calculator, and I'm going to do it. 15 times 240 equals, there it is, 3,600. So I write it down. Now, what about the units? The units of power are watts. And I can check my units because amps times volts is watts. So the units worked out right. So that's dimensional analysis, looking at the units to see if you did your problem right. And it looks like I did. Now, if you want kilowatts instead, that's a more common unit for everyday power. It's what like your rating for your refrigerator is in and your electric bill. You can change watts to kilowatts by this little thing right here. King Henry's daughter bakes delicious chocolate muffins. We're at the basic unit of watts, and we want to go to kilowatts, and that's 1, 2, 3 frog hops. Do you see that? Okay, so that means I can take my decimal point that was right here and frog hop it 3 times. 1, 2, 3. And I know that it's 3.6 kilowatts. All right, we'll do that again on the next one if that one didn't make sense. All right, so our next problem is on the next page, page 212, and we're going to do it again. Okay, so we're going to get rid of the words and make it just a problem. A microwave oven with a power rating of 1,200 watts. Ding, 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 there's our first number, and it's a power. So we go over here when we write 1,200 watts. Okay, then it says, is used for 0.25 hours. So that's the time. So I write time equals, and you can put a 0 there, 0.25 hours, okay? How much electrical energy? So my question word, how much, goes with energy, is used by the microwave. So I put energy question mark. Now I think to myself, Is there a formula that relates power, time, and energy? Why, yes, there is. It is energy equals power times time. I write it down. I sing substitute. I write the power underneath the P and the time underneath the T. But remember I told you they gave this to us in watts. And remember I told you with appliances, they don't use watts, they use kilowatts. So I'm going to change it from watts to kilowatts. It's 1, 2, 3 frog hops. So I start right here, 1, 2, 3, and that is 1.2 kilowatts. Right? So that's what I'm substituting in here is 1.2 kilowatts. Sorry, I got this line. That was from when I was showing y'all screws. So that was the marker from me showing you how a screw is an inclined plane. Anyway, so now we multiply them. So on our calculator, we're going to do 1.2 times 0.25. You don't have to put your 0 in. Your calculator's okay without it. And it's 0.3. So 0.3 kilowatts, so kilowatt hours, and that's a very normal energy unit. So it's what a microwave oven would be in. All right, so and there's our problem from last time from chapter 6. So do your math, practice it, have fun. Remember, science is great. Like, share, subscribe, and I will see you next time.